Okay, we want to calculate these two limits. In both cases, they involve a primitive that is difficult to calculate or impossible. And both are of the form 0 divided by 0, right? Because the integral from 0 to 0 of this is equal to 0, and this is 0, and down here we have 0. So we have in this one, this integral is 0, and then you have 0 down here. So these are indeterminacies, 0 divided by 0. So we have to calculate these limits. The problem here is the derivative, but if we apply L'Hopital to any of these, then we get rid of the complication. So let's focus on the first one. So we have an integral here. Well, we have a function defined through an integral divided by x cubed. Let's apply L'Hopital once. So we take the derivative of this, but the derivative of this is just this function over 3x squared. We could continue applying L'Hopital, but we don't have to, because the exponential of u is equal to 1 plus u plus ou when u goes to 0. And if u is equal to x squared, what you have is x squared is equal to 1 plus x squared plus ox squared when x goes to 0, right? So if I substitute this here, then we have the limit when x goes to 0 of 1 plus x squared plus ox squared minus 1 over x squared, 3x squared, right? And then the 1 cancels, and this is the limit of when x goes to 0 of 1/3 plus O1, which is 1/3. So that is the limit of the first one. Now the second one, before we get into matter, we have here, well, you can see here that you have a cosine, right? And the cosine makes no problem, because the limit of the cosine when x goes to 0 is just 1. So we can just factorize it, and the limit we want to calculate is the limit when x goes to 0 of the integral from 0 to x of the sine of t cubed dt, right, over x squared. And to calculate that, what we do is we apply L'Hopital, right? So we calculate the limit when x goes to 0 of the derivative of this, which is sine of x cubed, divided by 4x cubed. And that's it, because, well, actually this limit, the sine of x cubed over x cubed when x goes to 0, the limit of that is 1. So this limit here is just 1/4.